Looks like we got an animal that looks a little bit different. And to understand how to use this animal, we're going to use something called the quotient rule, or the quotient rule for radicals. And that basically says that if I have an n root of some fraction, let's say the nth root of a over b, I can rewrite it as the nth root of a over the nth root of b. Basically, I can split the numerator and denominator up into its individual roots. Well, how does that apply here? The first one I have is the cube root of 16 over 27. So I can rewrite the cube root of the entire thing as the cube root of 16 over the cube root of 27. And I can reduce it to see if it reduces down. The cube root of 16, well, 16 is a factor of an 8 times a 2. The cube root of 27 is a 3. The cube root of 8 is a 2 with a cube root of 2 left over, all over a 3. So my final solution then on how I was able to do this problem, the cube root of 16 over 27, I broke them up by using the quotient rule, made it a cube root of 16 over the cube root of 27, and then just worked through and reduced the problem as I continued on. Let's look at another one. I have the square root of x squared over 20y yx. Quotient rule says I can break them up into the numerator, so I have a square root of x squared over the square root of 25 y to the 6th. Square root of x squared is an x, square root of 25 is 5, and the square root of y to the 6th, y cubed. So x over 5y cubed. And our last example that we have up there, the fourth root of 7y to the 5th over x12. Quotient rule says break them up into their individual ones. Looks like this top one can be slightly reduced. So it's the fourth root of 7 times y to the 4th times y all over the fourth root of x to the 12th, and that's x to the 3rd. And then what's left on that top one is the fourth root of 7 y to the 4th. The fourth root of y to the 4th is a y, so I can pull him out. Y is left inside all over my denominator, which is x cubed. So that's my final answer for that last problem that we had right there.